All right, so for this video, we're going to go over some more qualities or characteristics of rectangles, rhombi, and squares. So the first one we want to talk about is another theorem that states that the diagonals of a rectangle are congruent. Right, so remember that the diagonals are the lines you draw from one opposite angle to the other. Right, so these two lines are the diagonals. So let's say if this is a rectangle A, B, C, D, then this means that segment AC would be congruent to segment BD. Right, those two lines here are the exact same length. All right, so the next two theorems that this section covers are both about a rhombus. So the first one says that each diagonal of a rhombus bisects two opposite angles. So let's draw a rhombus. Yes, you can probably hear my cat meowing in the background. He's mad that I won't give him treats. He's had plenty. So diagonals of a rhombus. Right, so it says they bisect two opposite angles. So it means that this is congruent to this. This is congruent to this. Also, these two here are congruent. Okay, and then the other theorem says that the diagonals of a rhombus are perpendicular. So that means that these four angles here in the middle are all going to be right angles, right? They're going to form 90-degree angles with each other. All right, so now I want to do a couple examples of just how we can use this information to find missing pieces. So like missing side lengths and angles in these quadrilaterals. Oh, and also, I know we, in that example, really just specifically talked about rectangles and rhombi, but that would also mean that all of those things are also going to apply to a square, right? Because a square is a rectangle and it's also a rhombus. So all of those things are going to apply to a square. Okay, so I've put a rectangle here. And then some different example problems that we are going to, I thought I could move all four of those at once, solve together. So looking at this rectangle, right, we have rectangle STUV, point W in the middle, and it's saying that the length from S to W is 4, and here we have a 60-degree angle. So looking at this, remember that if we've got a triangle, with a 60-degree angle, right? That means that, and we have this is 90, right? So this first angle we're looking for is WTU. So we're looking for this angle that I'm going to kind of color in yellow right here. Right, so again, we know that this is a 90-degree angle. So we would do 90 minus 60 to get that the angle I put in yellow is 30 degrees, right? Because those two angles have to add up to 90. Okay, and remember we also learned, oh, sorry, getting ahead of myself there. Okay, so we're looking for WU, so that is this piece right here. Right, and remember what we learned in the last section about parallelograms, right? So the diagonals of a parallelogram bisect each other. So that means that this is also going to be 4. And then remember that the diagonals of a rectangle are congruent. So that means each of these other pieces are going to be 4. Right, so WU, so from the middle to here, is 4. Right, and then T to V, so that goes all the way across. So that would be 8, and then T to W would also be 4. Okay, and then in this next example, we're finding the measure of angle TSW, right? So we're looking for this angle right here. So, looking at this triangle here that was formed, let's highlight it. Let's make it purple. So this triangle here, right? So we know that the side lengths of each of those two is 4, right? So let's just kind of copy that down here. So if that's 4, that's 4. That means this is an isosceles triangle, which means that the base angles have to be congruent. So if this angle is 60, that means this angle also has to be 60 degrees. And if we have a triangle that has two 60-degree angles, that means that the third one would also have to be 60, which is angle TWS. Right, and then we kind of have the same thing over here on the side. So we're looking for TWU. So we know that this angle up here was 30. Let's get another color going on here. Let's go with this navy color. So we know this is 30. And since these, again, both have this length of 4, that means this is also going to be 30. So we have a triangle that has two 30-degree angles. So we're going to do 180 minus 30 and then minus another 30. So essentially 180 minus 60, which is going to make this angle equal to 120 degrees. Right, and we just found WUT as 30 to get TWU. Right, so the biggest thing is you need to remember that the diagonals are going to bisect each other, right? So everything we learned about parallelograms is going to still apply to all the rectangles, the rhombi, and the squares, right? Because all of these things are still technically parallelograms. So you kind of have to keep that in mind as you go on through. Like, you can't just, like, forget the stuff that we just learned. You have to still apply it to these things. So this is really where it's starting to build on itself. And remember that we know that rectangles have 4 right angles, which comes in handy while you're trying to break down what the angle measurements are. We also have to remember that the base angles of an isosceles triangle are congruent to each other. So we have to kind of use everything we've learned in geometry so far to find these missing pieces. Okay, please be sure to post a picture of these notes on LMS for your assignment for today. And we will do some practice problems with this together in class tomorrow. Hope you guys enjoy your snow day. We'll see if it actually snows. Hopefully it does. So enjoy your day.